So myself, Sricharan Mahavadi. Today we'll talk about the storage management aspect for primarily workloads that run using keyboard-based virtual machines on Kubernetes, right? So for the first few slides, we'll talk about why we need to run virtual machines on Kubernetes and what are our options to run virtual machines on Kubernetes or GDC, and then we'll look into some of the considerations and challenges of running the VM workloads on Kubernetes, and then we'll slowly transition into the storage solution for that. And then we'll look into some of the aspects that we're working with GDC to build an integrated solution. So it's needless to say, Kubernetes has been chosen as a de facto modernization platforms to run your workloads. While a massive amount of your workloads are running on containers, refactoring some of the legacy workloads still is very complex, and some of these applications are refactoring them back into the containerized workloads are too complex, costly, and significant effort for the enterprises. So this drives for a need to have a unified orchestration platform to run both the VMs as well as the containers next to each other in the same Kubernetes platform. So, you can, there's a need to, and the Kubernetes comes with a large ecosystem that can be leveraged for both the VMs and containers, and they can convert into same operational management workflows. From resource management side of the things and observability and various other things. And especially for having your deployments at edge, where you need to run your VM-based and container-based workloads at the same place, would be very seamless if you were to containerize or make your virtual machines run as a cloud-native VM workloads. So what are the various options? Okay. Yeah. So how can you get the VMs run on Kubernetes, right? So you have a KubeVirt which extends the Kubernetes management, which runs as a custom resource definition on the vanilla Kubernetes. It's an open source CNCF project, and it allows you to run both VMs and containers in the same infrastructure. And Google Distributed Cloud, GDC, comes with basically builds on top of the KubeVirt and extends and operationalizes and productionizes the VM capabilities. It enhances the capabilities in the storage, network, compute, observability, security, and many more. And folks from the Google out of the booth could probably cover the things up. So as you see here, the VM is running inside inside a KubeVirt pod. It runs both KEMU and KVM2. It runs KEMU hypervisor. So let's understand some of the challenges for running the VM workloads in Kubernetes, right? So while you can run your KubeVirt-based VMs using local storage, but local storage can't really scale as your business grows. It cannot tolerate any faults that are there in the systems. Let's say your disk were to go down, your host were to go down, your rack were to go down, then there's no resiliency built into the platform, right? And it comes with issues with the data security, and then you cannot have the live migration capabilities for which you require a CSI compliant storage. And definitely the complexities involved around managing the local storage-based VM workloads would be difficult from data perspective, right? And the insights into the sizing aspects of storage management and all those things becomes too difficult. So some of the key considerations one has to consider when choosing the right storage solution for making your journey towards making the VM more cloud native is to make sure the storage stack that you're taking, you're choosing is predictable in performance. It supports heterogeneous kinds of media types, HDDs, SSDs, NVMEs, It has to be resilient for any of the unforeseen failures, faults. It has to come with end-to-end data protection. Both in flight and rest, and data availability and support for live migration and so forth. So it has to have all the required operational toolkits for you to run production-grade workloads on Kubernetes, right? And unlike any other cloud-native application, it has to be declarative in nature. The storage stack should be API-driven. It has to come with a rich observability toolkit. It has the storage stack has to give all the insights of the various storage resources that are deployed, so that the operator gets to draw useful insights and make operational decisions based on that. It has to be a fully CSI compliant Kubernetes software vendor. So here's what is Rakuten Cloud-Native Storage, right? So Rakuten Cloud-Native Storage is a software-defined scale-out storage that enables both container and VM workloads to run on Kubernetes or in Google Distributed Cloud. It can run both virtual machines. You can run Windows virtual machine or Linux virtual machine, or you can run your stateful container-based workloads on your Kubernetes cluster at edge. So we will talk about some of the things that we were working with GDC and some of the solutions that we're working together. Okay, so it basically provides both block storage as well as the file storage. It works directly with your direct attached storage, your SAN drive, and if you're choosing to deploy cloud-native storage on GKE, we also are compatible with the cloud disk. You can we discover heterogeneous media types like HDD, SSDs, NVMe, and any flavored Kubernetes. It's all built homegrown, choosing the best design principles for the ease of management, operational ease of operations, and make it observable and for the best performance. So let's understand the high-level architecture of Rakuten Cloud-Native Storage, right? So imagine that you have a 3-node cluster at your edge, and your Kubernetes or Anthos or GDC services that are running, and you have a cloud-native storage control plane service that runs as a master service, and you have data services that runs on each node of your Kubernetes cluster as a daemon set. And once CNS operator is installed, we basically discover all the drives and then creates a storage pool, and we use this storage pool to cater it to the applications that are deployed using the cloud-native storage class. So as you see here, you can choose to have your VM with a single-way replica or with a 3-way replica. As you see here, you can have a volume with one replica on each node, so it is resilient for any of the failure. Or you can have your VM to deploy it with 2-way replica, or you can deploy a VM or a pod with a single replica. And then also you can also choose to have a volume with a read-write many capabilities, where you can have the same volume which can be mounted across 2 different application VMs or pods or of any type, right? So you can choose to deploy your virtual machines. It could be Windows virtual machines on Kubernetes, or it could be a Linux-based virtual machine on Kubernetes, or you could choose to deploy any stateful pod. So so this gives us a sample VM spec. As you see here, the kind is a virtual machine disk, and you're basically defining a virtual machine, an Ubuntu-based virtual machine, and defining the disks. And these disks are essentially using a storage class called Robin. So Robin storage class is basically our storage class, which basically gives the various capabilities. As you see here, the Robin storage class here has the various options that you can choose based on your requirement. You can choose to have a file system. You can choose to have your volume created with a file system type XFS. You can have a replication of 2 or 3 and can configure your replication's fault domain to be host, disk, or whatnot, right? And then you can have your replication. You can enable various other configurations as you see. You can choose to have your different block size and choose to have a different media, SSD or NVMe. So whenever an application is deployed or a VM is deployed with this particular storage class, it always adhere to the parameters that are defined for this particular storage class, and then your VM will get all the capabilities that are defined here. Yeah, so as you see here, once a VM is deployed, the Ubuntu VM, as you see, the VM is running, and the virtual machine disk that are part of this VM is also running, and it uses the underlying Robin RWX storage class, and it creates a PVC, and these PVCs are basically binding the virtual machine disks, and then the VM is disconnected. So here's a quick demo of a sample deployment. As you see, once a Robin is installed, it discovers all the drives and all the resources of the edge to Kubernetes cluster, and once it discovers, it basically creates a pool of all the storage and then deploy. And here it's deploying a simple point-of-sale application. So this is a VM that gets deployed. It has, as you see, the virtual machine is running. And then it is using a virtual machine disks. So as you see here, these are the two virtual machine disks that got created. And so as you see here, the point-of-sale application is using the Robin storage class and deployed a virtual machine. Right? Yeah, so some of the problems we solve along with GDC, we have engineering to engineering collaboration that we're working to provide, making sure at your edge deployments, your VMs are getting making sure the VM and the workloads deployed at the edge are highly available, and it is adhering to the data locality if you're choosing to deploy it at your stateful application at specific edge locations. And the management, data management, storage management, lifecycle management of your stateful workloads at edge is seamless and declarative, and we can provision, take snapshots, backups, we can restore, clone your VMs all through single APIs and declarative way. Various other observability and management of storage management becomes seamless, and we have a rich command line, UI, and metrics available to manage the day two operational needs. Any questions?
Have you deployed this in US in any way? Or?
Yes, we have a few joint customers along with GDC. Yeah.
Scale of those, like how large?
Yeah, I mean, yeah, we have pretty large scale deployments. Yeah. All right, thanks everyone.